Okay, so welcome to 5.2, the sum and difference identities. The sum and difference identities. Okay, so let's recall. The distance between 2 points in the plane. So the distance between 2 points, 2 points in the plane. Let's say they are x1 comma y1 and x2 comma y2 is given by so the distance is going to be the square root of the difference between the two x coordinates quantity squared, that is x sub 2 minus x sub 1 quantity squared, plus the difference of the two y coordinates quantity squared, that is y sub 2 minus y sub 1 quantity squared. Okay, so squaring both sides, what this implies is that the distance squared is simply the difference in the two x coordinates squared plus the difference between the two y coordinates squared. And this should look like the Pythagorean theorem if you're paying close attention. Okay, so let's consider So what I'm going to do is I'm going to focus on the first quadrant, let's see, of the unit circle. So let me try and draw just the first quadrant here. So 1 and 1. Don't know if it'll let me draw a nice curve, something like that. No, it's not going to let me do it. Okay, so let's see. Okay, so I can kind of do it that way, maybe. And then erase the rest of it or something like that. Maybe I'll try that. Erase the rest of it. Okay, that kind of works. Good enough for government work, so I'm just going to copy and paste this. Copy, paste, because I'm going to need another one in a moment. Okay, so we're on the unit circle. And let's say I've got, sorry, a point A here corresponding to an angle alpha. And then let's have a point B somewhere else in the first quadrant for ease of doing this at another angle. Let's call it, oh, that's terrible. Why does it autocorrect to places I don't want it to? Because I have no choice. Okay, great. And let's call this at an angle beta. And what I want to do is consider the distance between these 2 points. So what is the coordinate of point A if I'm on the unit circle? Do you agree that the coordinate would be cosine of the angle, comma, sine of the angle, because I'm on the unit circle? So similarly, the coordinates for B will be cosine of the angle beta and sine of the angle beta, that is the x and y coordinate respectively. So what were to happen if I were to rotate this so that B was flush with the x-axis? So now B has coordinate 1, 0. Oh, and I didn't label my axes. X and Y, shame on me. Okay, and we've rotated this, so A is, what about here? So, what is the angle? Basically, I'm looking for this angle here. What is the angle between the two? Well, I claim that this is alpha minus beta. The larger angle minus the smaller angle. So therefore A, in this case, let's call this A1, A2, B1, and B2. I claim in the second case that this will be now cosine of the angle alpha minus beta, comma, sine of that same angle, alpha minus beta. Because I've rotated so that one of my points is easier to analyze. Actually, let me move this a bit to left so it's not off the page. There we go. Okay, but notice, is the distance between the 2 points any different? And I claim that it's not. So I claim that the distance, let me use a different color, that the distance from point A1 to point B1 is exactly the same as the distance from point A2 to point B2, because all I've done is rotate them and I haven't changed the distance between them. Okay, so let's consider then the square of the distance between points. Let's do A1 and B1 first. So that is, I don't need to write the square root if I'm squaring the distance, but I know that it's the square of the difference in x coordinates. So let's do cosine beta minus cosine alpha quantity squared plus the difference of the y coordinates, which will be cosine beta, sine beta minus sine alpha quantity squared. Okay, so what does this give us? Well, expanding the binomial, I know that it's first guy squared, so this will be cosine squared beta. Then because it's negative inside the parentheses, it'll be minus 2 times the first, cosine beta, cosine alpha. I guess if I wanted to, I should have put that in order. I'll do that in the next step. Actually, no, let me do it right now. That's going to drive me crazy. Alpha should come before beta. Not that it matters, it's all multiplication, but you know, that looks better. Okay, and always plus, so plus the second guy squared, so that'll be cosine squared alpha. And then I'm going to add to that, let's see, do I have much room? I'll put it down here. The square of the second parenthetical, which is sine squared beta. Then minus twice the product of the second and the first. Let me do sine alpha, sine beta. And then plus the second guy squared, so plus sine squared alpha. Okay, well, let's notice something. If I look at cosine squared beta plus sine squared beta, that's the Pythagorean identity for 1. Similarly, if I look at cosine squared alpha plus sine squared alpha, that's also the Pythagorean identity for 1. So what remains will be minus 2 cosine alpha, cosine beta, and minus 2 sine alpha, sine beta, sine alpha, sine beta. And of course I can combine these first two into the number 2. So it's 2 minus 2 cosine alpha, cosine beta, minus 2 sine alpha, sine beta. Okay, so that's the distance between A1 and B1. That is the left-hand graph. Now let's consider the distance, and you know what, I'd like to change the color here, just so I know I'm using different, let's call this blue. Now let's do the distance squared between A2, A sub 2, and B sub 2. Which of course I know will be the same distance when all is said and done. So that's the square of the difference between the two x coordinates. So that is 1 minus, because over here the b x coordinate is 1, and this will be cosine of the quantity alpha minus beta, and we're going to square that, plus 0, so quantity 0, minus sine of alpha minus beta, all quantity squared. So sine of alpha minus beta, quantity squared. Okay, so expanding this binomial, this will be 1 minus 2 times the product of the first and the second, which is simply cosine of alpha minus beta, plus the square of the second, so cosine squared theta, cosine squared of the quantity alpha minus beta, to which I'm adding the square of sine of alpha minus beta. The negative goes away when we square. So sine squared of alpha minus beta. And notice once again that cosine squared alpha minus beta plus sine squared alpha minus beta, that's the main Pythagorean identity. So what I have here is I have the 1 plus the 1 from the main Pythagorean identity minus the 2 cosine of alpha minus beta. That is, I can rewrite this as 2 minus 2 cosine of alpha minus beta. And if these two distances are indeed the same, which I claim they are, then I can rewrite 2, wrong color. Let me just copy and paste this. I can rewrite 2 minus 2 cosine of alpha minus beta as being the same as this quantity here. Okay, that is, I'm saying the distance between A1 and B1 here is the same as the distance between A2 and B2. I've just rotated the 2 points. Okay, so now, do you agree that if I subtract 2 on either side, those go away? So what I'm left with then is negative 2 cosine alpha minus beta is equal to everything except that initial 2. And then what I can do is I can divide each term by the coefficient negative 2, and each term has a coefficient of negative 2. So what I get then, finally, when all is said and done, that is, once these negative 2's reduce in each term, I get that cosine of alpha minus beta is equal to cosine of alpha times cosine of beta plus, because 2 negatives make a positive, maybe I should do that in blue so we see where that came from. So plus sine of alpha times sine of beta. Okay, so this is one formula we will be coming back to. This is the difference formula for cosine, and why did that not work? There we go. Okay. So let's note in this formula, what do we know about cosine? We know that cosine is an even function, right? So that is, if I have cosine of a negative angle, that's the same as cosine of a positive angle. And that's because cosine is even. Cosine is even. Okay, so this would imply that I could write cosine of alpha plus beta as cosine of alpha minus negative beta. Agreed? And actually, let me color code these so I see what's going on. Let's call this purple. Call this purple. But I want that to be orange still. Okay, so according to the rule above, should be cosine alpha. Then in purple, cosine of the second guy, which is negative beta. And then plus, let's do sine of the first, alpha. And then sine of the second guy, negative beta. But what type of a function was sine? Sine was an odd function, right? So we know that since cosine is even, cosine of negative beta is the same as cosine of positive beta. However, sine is odd. Since sine is odd, it'll be negative. So this is minus sine of alpha, sine of beta, because the negative came out in front. Okay, so I have another identity, namely cosine, oops, wrong color, keep on using the wrong color, cosine of the sum alpha plus beta is cosine of the first times cosine of the second beta minus sine of the first alpha times sine of the second beta. Okay, don't worry, I will recap these. I just want to show you how I'm deriving them. Hopefully that, yeah, that was pretty bad. Okay, let's see, how can I just want, yeah, okay, better. Okay, let's recall. That sine of theta is actually cosine of pi over 2 minus theta. We got that from section 5.1. And we also know that cosine of theta is sine of pi over 2 minus theta. Okay, so let's consider the following. So consider if I want to find sine of alpha plus beta, I claim that that's cosine of the quantity pi over 2 minus the whole quantity alpha plus beta. And so I claim that that'll be cosine of the quantity. Let's do pi over 2 minus alpha and then minus beta. Okay, so let me color this now purple. So cosine of one angle minus another is cosine of the first. So that's cosine of the first angle, pi over 2 minus alpha, times cosine of the second angle, cosine beta. And then the sign is the opposite, so plus sine of the first angle, sine of pi over 2 minus alpha, times sine of the second angle beta. Okay, but what do I know about cosine of pi over 2 minus alpha? Well, that's the same as sine. Okay, so I'm going to write this as sine alpha cosine beta plus, how can I rewrite, what color should I use? I guess I'll use yellow again. How can I rewrite sine of pi over 2 minus alpha? Well, I can write that as cosine of alpha sine beta. Okay, so recapping, what I get then is sine of alpha plus beta can be written as sine of the first alpha times cosine of the second beta plus cosine of the first alpha times sine of the second beta. And like I said, I will recap all of these identities once we get them all derived. Okay, well then let's note. We know that sine is odd, right? So sine odd implies that sine of a negative angle is negative sine of the angle, agreed? So sine of alpha minus beta, I can write that as sine of alpha minus a negative beta, agreed? Let me make that negative beta be purple. So now according to the rule above, what I do is I do sine of the first, then cosine of the second, which is negative beta. Then I do plus cosine of the first, cosine alpha, times sine of negative beta. So I know that cosine is an even function, which means that cosine of the negative angle is the same as cosine of the positive angle. However, sine is an odd function. That means I need to factor out the negative here. So this is going to be minus minus cosine of the first angle, alpha, sine of beta, where the negative came out in front of that term. So to recap, I have that sine of alpha minus beta can now be written as sine of the first, alpha, times cosine of the second, beta, minus cosine of the first, alpha, times sine of the second, beta. Okay, I think we can finally recap at this point. And these are called the sum and difference formulas. Well, maybe if I can draw a square, we can recap this. Yes, okay. So the sum and difference formulas, what am I saying? Okay, so sum and difference formulas. Sum and difference formulas. Okay, so yeah, let's do cosine first. So we have cosine of alpha plus beta is going to be cosine alpha cosine beta minus sine alpha sine beta. Whereas cosine of alpha minus beta is going to be cosine alpha cosine beta plus sine alpha sine beta. So I want you to notice something before I do the signs, is that cosine, the SIG ends are always the opposite. So if it's alpha plus beta, then I know I'll have a negative. And if it's alpha minus beta, then I know I'll have a positive in my sum to the right. What's more, is cosine puts himself first twice. Cosine puts himself first twice. So he changes the sign and he puts himself first. Well, what does sine do? Okay, let's look at sine of alpha plus beta. Well, that's going to be sine alpha cosine beta plus cosine alpha sine beta. Whereas sine of alpha minus beta will be sine alpha cosine beta minus cosine alpha sine beta. So what's going on with sine? Well, sine is much nicer, right? Because the sine and the sine are the same. So therefore, plus goes to plus, minus goes to minus. So that's kind of nice. Let me move that up a bit. And what's more, sine shares each term with cosine. Sine does not put himself first, so sine is in each term as is cosine. So sine is the nice guy. Oh, I did that wrong. Hold on. Underline the wrong guy. This should have been sine. So sine is in every term, and he does not put himself first, and he keeps the same SIGN signs. Okay, so that's it for right now. The section is not done, but this video is.